So I don't know how well this will work out, but I thought it might be interesting to see if there's any correlation between home price returns or home returns to volatility. And this might be just like poorly set up to begin with, but let's try it anyway. If you've seen other previous videos, I've talked about Spearman as a way of calculating if there's a statistically significant correlation between volatility and the returns that you're calculating for the asset price. So in this instance, we're going to be using the FRED, the St. Louis Federal Reserve API data set. There's tons and tons and tons of data over there. And so I think it's worth setting yourself up with a token and getting access to this data. So you just connect to the URL. This is the endpoint. We want the observations. You're using this indicator. So this indicator happens to be US home price index. I pass through my key. This is the parameters. When you get a request, it comes back in a JSON. I just want the observations, and I drop real time and real time end. These are two date time columns that I'm not really interested in. I just want the observation date time. I convert those dates to make sure that they are actual date time and the values to make sure that they're actually numeric values. I set the index to date. So we pretty much just have a series here where it's like a home index. So you can see that there's no price for this period here, but if we keep going, you can see I have 144 instances where there's NA. So I'm just going to drop those NAs and then plot it. This is what the data set looks like. It's just an index, and I don't think that will have too big of an impact on it because my idea is that that we could do the same thing for the S&P 500 index, and that price doesn't necessarily mean that number doesn't necessarily need to be like 100,000, 150,000, 200,000. It could just be 200, 300, 250, whatever it is, because you can still derive volatility off the number. It's just scale at a different point. I also think that this data set is already accounted for inflation, but you could read more of that on um, inflation or CPI or something, and it's already adjusted, which is why it's not huge values here. So we're gonna calculate the volatility of the home price with a rolling window of 6, since the date time is month by month. I figured 6-month window is a good idea um, for volatility. There's no like special, or there's no like great way of doing this. I tried it with greater numbers and less numbers, but 6 seemed to give me a nice area for which I could calculate volatility, if that makes sense. Excellent. So then we do the lags. So the idea of lags is that you are calculating the return based on the window here. So this return here is calculated by the um, percent change of 1 day. So these two here gives us this, and so on and so forth. So we did 1 month, 7 month, 12 month, 24, 48, 120, and that gives us our monthly volatility or our monthly returns across that window span. We do the same thing for targets. So what this is doing is it's shifting everything back. So this is our return for this row, but our target should have this value on this row. So we know what our target value is, our target return value is based on the percent change that we've calculated in our returns. Cool. So it looks like this. You can see here's this number. It's now shifted back to where it should be. This number would be like seven instances up, and so on and so forth. It's all shifted back to where it needs to be. Cool. So now we can use a joint plot to visualize our metric for our target. And then we're going to use the spearman to calculate the p-value of our correlation here. And from there, well, let's just run it. You can see what it'll look like. So basically, we get a 0.241, which is not statistically significant enough for us to um, say that there is a correlate that there is a statistically significant correlation between volatility and returns for a 1 month period. So yeah, so you would say like doesn't mean as volatility gets greater does not mean that you're going to get greater returns. It's just not true for on a 1 month target. But you might say, well, what about 48 months? So like 2 years out, you buy a home, you hold on to it. In general, what would your, if it's a volatile market, are you going to make returns in a 2 year span? The answer is no. The correlation is actually less than if it was a 1 month span. And you also get this crazy looking graph here. It's like it looks like there's like waves, like some kind of sine wave or cosine wave in here of some kind, which I wasn't expecting. It's just like the distribution of target returns is so great, um, and even on low volatility. So even if you're making lower volatilities, your volatility is not, you're not making greater returns really on at any point of volatility. So that's my little experiment here. This is going to be a pretty short video, but I just wanted to see what would happen if we took weird data like this and see. I think it needs to be more locally centralized, so I might find because like this Fred data um, it has data for like municipalities, so like New York, California, etc. But even cities like Minneapolis, Boston, things like that. So I might stick to just like a location to see if there's any difference there in the volatility or not. It kind of makes sense that why you wouldn't see returns based on housing volatility, right? Really, housing returns are probably most likely correlated to other municipal investments in the municipality. Um, so yeah, pretty interesting though. If you found it, if you like it, if you like these videos, if you like being able to watch them and get little cookbooks, little recipes for doing algorithmic finance, consider downloading this in the description and going to this link here. You can provide a one-time donation. It really helps support the creation of these notebooks, and it really helps me justify spending time making these videos and making these notebooks and doing the research. And then I also don't have to, feel the pressure of accepting sponsors or creating a Patreon or a course. All things that I kind of don't like about YouTube. So, yeah, let me know what you guys think. And if you want me to do this kind of exercise on other types of assets or data types, I'd be more than willing to do that. Thanks. Thanks for watching and safe investing out there. Bye.